Alright, so now we have come to our question 15 right here. So question 15, we have A and B. We are going to start with A. The diagram in the answer space shows triangle ABC with vertices A 2,3, B 4,2, and C 4,4. Triangle ABC is mapped onto triangle A1, B1, C1 under a reflection in the line x is equal to 6. Draw triangle A1, B1, C1 on the diagram in the answer space. So this is what they are talking about here. So they have told us that triangle ABC is being mapped. Okay, it is being mapped on triangle A1, B1, and C1. Okay, under a reflection in the line x is equal to 6 on this line. So you need to take note of this line. On this line, okay, this is where this is the boundary. This was the mirror line, okay, which is x equal to 6. So now how can we come up with the triangle that was mapped onto A1, B1, and C1? So here what to do, just be measuring the distance or be counting the distance. So from this mirror line, from this line x is equal to 6 to get to B, how many steps are there? So count 1, 2. So you even come here, count 1, 2. So this is where we are going to have B1, okay? Then you come to this one also, you count from here 1, 2. So you come here 1, 2. So this is where we are going to have C1, okay? Then you come from here 1, 2, 3, 4. So you count from here 1, 2, 3, 4. So I hope it's clear there. So this is where you are going to have A1. So it's just a matter of connecting these points, as you can see. All right, so this is our answer. Okay, this is the triangle of which this ABC was mapped into triangle A1, B1, C1. So we have answered our question A. Let us now move on to our question B, which is this one. The equation of the curve is y is equal to x minus 2x squared plus 1 over x power 3. Find dy dx. So first thing, we're going to write the equation, which is y is equal to x minus 2x squared plus 1 over x power 3. So we need to find dy dx. So to find dy dx, first we will rewrite this one because I've seen there is this term which is a fraction. So we write x minus 2x squared, then we say plus x power negative 3. So the reason why I've written this one, if you have 1 over a power 2, we can write it as a power negative 2. So I've used this principle coming from the laws of indices to rewrite this one as well, which will be written in this case. So now we can find dy dx. So dy dx means that we are differentiating y with respect to x. So here x is raised to the power of a1, okay? So it will be x power 1 minus 1. That is the principle there, okay? So meaning that the coefficient of this x is a 1, which will be multiplied with a 1. That's why I've just written x power 1 minus 1. Then minus, so here we have a 2. So this 2 will be multiplied with this 2. So 2 times 2. Then we have x power 2 minus 1. Then we can say plus. So the coefficient of this x is a 1, which will be 1 times the power, which is a negative 3. Okay. Then we have x power negative 3 minus 1. So from here, we'll get x power 0 because 1 minus 1 is 0. Then minus 2x because 2 minus 1 to be a 1. So 2x power 1. Now I won't write a 1 here. Then we can have 1 times negative 3 to be negative 3. So negative times this positive to be a negative 3. Then we write x. Negative 3 minus 1 to be a negative what? 4. So this is what we are going to get here. So we can say x power 0, it's a 1. Then minus 2x. Then minus 3x power negative what? 4. So I do hope that you are following there. So from here, we can now write our final answer as 1 minus 2x minus. So again, for this one, I just have to write it in this way, like 3 over x power 4, so that the power becomes a positive, okay, not the way it was a negative. So this is our answer. We have answered this question. All right, so we are now on question 16. The question reads, it is given that a varies as b and inversely as the square of c, and a is equal to 9 when b is equal to 12 and c is equal to 2. Find the a value of k, the constant of variation, b the value of a when b is equal to 16 and c is equal to 4, c values of c when b is equal to 25 and a is equal to 3. So here we need to come up with the variation equation. So it is given that a varies, okay, a varies as b and inversely as the square of c. So a here is varying directly as b. So we write our variation equation. We'll start like, we'll say a varies as b. So we need to have this constant k and a b, and inversely. So because it's varying inversely as the square of c, so it will be c squared. This is how the equation will look. So it will be a equal to kb over c squared. So from here now, we can find the value of k, which is the constant of variation in this one, by using the first values we have been given. A is equal to 9, b is equal to 12, c is equal to 2. We just substitute where there is a, we'll put a 9. So 9 equal to, so this will be k times, what is the value of b? It's a 12 right here, over c squared, meaning 2 times 2. 2 times 2. So I hope this is clear for you. So from here, what are we going to do? We can have 9 is equal to k times 12 over 4. So we can say 4 here, 4 into 12, it's 3. So we have 9 equal to 3k. So you can divide by 3, even here by 3, k, okay, then k is equal to 3, because this and this will cancel. 3 here, 3 into 9, it's 3. So the value of k is a 3. Okay, so we have answered our question A here. Now let us now come to our question B. So question B, don't forget to use this same equation, which is A equal to kb over c squared. So they are saying find the value of A when b is equal to 16 and c is equal to 4. So we are finding now this A. So we say A equal to k, we have found that it's a 3. Okay, so 3 times b is equal to 16 over c is equal to what? To 4. So it will be 4 squared, because the c is squared here. So this will give us A equal to 3 times 16 over 4 squared means 4 times 4, which is also 16. So we can cancel this 16 here 1 and this 16 here 1. So we have A equal to 3 times 1, it's a 3. 1 into 3 we get the same number 3. So A is equal to 3. Okay, then we can come to C. So I hope we are following here. So for C again, we are using the same equation, which is A equal to kb over c squared. So they are saying find the values of c when b is equal to 25 and a is equal to 3. So here we find the values of c, values. So meaning that c is going to have two possible values. A, they have given us is a 3 here, equal to k, we know that it's a 3, that's what we found. B, they have said it's a 25. So times 25 over c squared. I hope this is clear. So what are we going to do? We can do this. We divide by 1, then we cross multiply. 3 times c squared. We are going to get something like this. 3c squared is equal to 3 times 25, because this we multiply by 1. So we divide by 3. Even here we divide by 3. So this and this will cancel. C squared is equal to this here 1, here 1. So 1 times 25, you get 25. So we can introduce the square root here. So we can say c squared is equal to plus or minus the square root of 25 is a 5. Okay, so sorry, this and this will cancel, no need of putting this. So therefore, c is equal to 5 or negative 5. So these are the values of c. Okay, so our answers here, the first one we are finding k. We said k is equal to 3. The second one was a is equal to 3. The last one, c is equal to 5 or c is equal to negative 5. We are done answering this question. So let us now move on